This week we're going to look at how to download level 3 radar data and make plots like this really easily using some of the new remote data access features in MetPy. Welcome to another MetPy Monday. Hello, I'm John, a software engineer for NSF Unidata, and today I want to show you how to use some of MetPy's newer features to access the NEXRAD Level III archive and how we can process that data in such a way that it's easy to create images using Matplotlib. So, like all Python things, we're going to start off with a bunch of imports. In this case, we know that we're going to need dates and times to get data, so we're probably going to use datetime. Pathlib, so we know where to save files. If we're making a map, that means we're going to be using Cartopy and Matplotlib. And we're going to be doing some radar data manipulation, so we're probably going to need some calculations and I/O tools to read files in and out, as well as a way to access that remote archive. So it's going to be a substantial block of imports this week. So from datetime, we're going to import the datetime object and the time delta object. From pathlib, I'm going to import the path object. And let's see, I'm going to go up here and import cartopy.crs as ccrs for our coordinate reference system. Import matplotlib.pyplot as plt. Import numpy as np. And then down in this block, we're going to continue with some of our froms. So from metpy.calc, I'm going to import the azimuth, range to lat, lon, so we can actually map this data. From metpy.io, I'm going to import the level 3 file reader. That's how we can actually read that file into Python. From metpy.plots, I'm going to import US counties, since we're going to be plotting a smaller area than a whole state. Add timestamp and color tables. From metpy.remote, which this is new, we're going to import the NEXRAD Level III archive. And finally, of course, from metpy.units, I'm going to import the units registry just in case we need to do any united work. So what we're going to do first is get the data. That's part of that essential workflow that we keep repeating in MetPy Monday of import, get data, pre-process data, do our analysis on the data, make plot, and save. So what we're going to do here is use our new tool to see what data are available. For the radar site, I'm going to use KTLX. This is going to be another Central Oklahoma case study. For product, remember we're in level 3 world, so I'm going to use N0B, which would be the super res base reflectivity. Start is going to be a datetime object, 2023. This is going to be an April 20th case. And end is going to be start plus time delta of 2 hours. So I want to see how many radar sweeps I've got in 2 hours. My products that are available. I'm going to go ahead and wrap in list so we can see everything all at once. From our NEXRAD Level 3 archive. Again, use tab completion, saves you a lot of typing there. And I'm going to use the get range function. And if we look at the documentation for that, and we can do that using Shift Tab, we see that we need a site, a product ID, and a start and an end, which conveniently we've already set up in those few lines above. A site, a product, a start, and an end. I'm going to print found len products. So it's going out and seeing what is available in the archive for this station and this time range. And in just a second, we'll see, yeah, we found 73 products. What I want to do is loop over each of those products and create a map, and then I'm going to put that map into a directory that I can later pull and put in my slides, put in my paper, turn into an animation, anything I want to do. Now, of course, you can make an animation natively in Matplotlib, but we've done other videos on that. We're not going to do that. I'm going to focus here on creating a bunch of static images. My output directory is going to be path, and this is going to be relative to where I currently am. I'm going to call it level 3 images, and then outdir.makedir exist OK is true. So what this is going to do is create a directory called level 3 images, and if it already exists, that's okay. We're not going to error out, we're just going to keep running. All right, now we're ready to start making our plots. So just a few lines in and we're already ready to do this. I'm going to put some more global things at the top that are going to be generic to all the frames, like the extent. So I'm going to make my lat long bounding box here, and 34.85 to 35.65. So this is a relatively narrow window. It's just going to be around a couple of storms in this image. I'm going to get my norm and CMAP. If you need a review on color tables, what they are, how to use them, we have MetPy Mondays all about that as well. I'm going to get this color table with steps. I'm going to use NWS storm, clear, reflectivity, and specify, if we look at our docstring, the start and step value there. So those are going to be for all of our plots. And now we just need to loop over our data products and create a plot for each one. Now you could put a try except structure around this, and I would in fact recommend doing that if you're running this to make, say, a weather briefing where you're doing a lot of different sites and a lot of different times. For a case study, probably not as important to do that, especially if you're working in the notebook, but it could be good programming practice. Just a reminder about that. And we've discussed try and except as well as how to do automatic retries in other MetPy Mondays as well. So now I'm going to write my loop for I, prod in enumerate products. This is one of the really handy Python functions. So it's going to take that list products and it's going to return the enumerated number that we're on, so 0, 1, 2, 3, 4, etc., and the product from it. So you don't have to manually create those sorts of counters. I'm going to use an F string, processing, product, and since it's 0 based, I'm going to go ahead and put I plus 1, just so it's a little more human readable. Divide that by len products, so we sort of see the progress there. And then let's go ahead and print prod.name, just so we can see what radar frame we're on. And that data, I'm going to call it next, use prod.access. So super handy. That's how we get access to that data. Now you may be used, and I even imported the level 3 file utility up here. So if I had level 3 files on my hard disk, I wanted to be able to plot here, I would use this to read those. But what's really cool is we're not actually going to have to use that here. Now we could use that if we wanted to save these files locally, or if we wanted to have a script that could work with local or remote files. But we're already accessing this product through the remote data service, so I'm just going to start using it. My data dictionary out of this is our sim block, and we need to access in a couple of layers in that. Now you can go dig through and look at what all is in these headers and what all information is available. It's just not something that we're going to have time to go into here, but it's all documented and we have a lot of information on that in the docs as well. The data is my map data, and I'm going to mask the invalid data using mp masked array masked invalid on that data. Now, the data that comes out does not have lat and lon tagged to it, but we are wanting to make a map with lat and lon. So we're going to need to extract the azimuth and the range, which are the native coordinates the radar is putting out, and then use MetPy's azimuth range to lat lon to convert those to lats and lons. So our data dictionary is going to have a start azimuth and data dictionary end azimuth. I'm going to access the last element in there. And those units are units.degrees. So what that's going to do is create the azimuth for us that each of these beams would have been on relative to the radar. And I've got an extra parenthesis there. Then we need our ranges. It's going to be similar, except here we're going to use linspace to create a linearly spaced array. Starting at 0, and we're going to go to the max range from the NEXRAD. And data.shape -1 plus 1. So that's going to be how many bins we want to go to. So we're going to go from 0 to the max range. We're using the shape of the data array to determine how many bins there are. And we're going to add units.kilometers. So now we're ready to convert this to lon and lat using our handy azimuth range to lat lon function. So I'm going to pass that azimuth and range and the location of the radar itself. And now we have our coordinates figured out, so it's time to work on the actual plotting. I'm going to make a figure. I'm going to go ahead and specify my fig size. In this case, I'm going to go with something like about a 9 by 8. Next, we need to create an axis. Plot.axes. Projection, I'm going to specify using my Cartopy coordinate reference system as Lambert conformal central longitude. I'm going to make it the NEXRAD longitude, the central latitude. You can probably guess is going to be the NEXRAD site latitude. We're going to set the extent of this, so we don't see the whole domain, we see just the area that we're interested in using the extent that we specified above, and it is in lat and lon, so we need to specify that as plat Curie. I'm going to go ahead and add a feature, and I'm going to add US counties. And I'm going to use the with scale method, 1 to 5 million. And that's just going to give us county outlines, so we have some nice reference for where we are. And I'll make those a relatively small line width. We're in such a small area, we don't need states, countries, coasts, anything like that. But of course, you could add as much of those as you want. Now we're going to use P-Color Mesh, one of the most misunderstood tools there is probably in the Python ecosystem. We have an entire video on P-Color Mesh to help you understand exactly what it's doing. But for now, we've done all of our data work ahead of time, so its use is actually pretty simple here. Lon, lat, data. I'm going to use the color map that we grabbed before, as well as the color map norm. And we just need to specify we're giving it lat lon. So again, that's plat Curie. We'll add a color bar on. Every plot needs a good color bar. That's going to take that handle to our mesh. We'll plot it on our main axis. And I'm going to adjust the padding and shrink it down just a little bit so it fits the plot a little more nicely. These are things that you can iteratively tweak and change to make it look like you want. I'm going to put a label on it, reflectivity, DBZ. And then we probably ought to put a timestamp on because we're going to be getting just a lot of plots out of this, 73 plots to be precise. So we're going to use the add timestamp method on our axis. We're going to go into the metadata on this NEXRAD product and use prod time. And I'm going to go ahead and specify my Y location. My contrast is going to use the high contrast method. And pretext, by default, it's going to add a created. I'm going to just set that to be nothing. Okay, so now our plot is done. So the out file name that we're going to give is our output directory that we've created. And one of the nice things about pathlib, you use a slash like you're going to divide, but it's creating the path. And I'm going to call it frame underscore. And let's see, what do we call our indexing variable up here? We just called it I very creatively. And I'm going to specify that I want that to have 0 padded 3 place integer .png, plot.savefig, out file is our file name and path, bbox inches is going to be tight to trim that figure up as much as we can, plot.close fig. This is really important because otherwise you're going to leave all these plots open in memory and it can get really slow and start eating a lot of memory. So let's go ahead and try to run this, see if we've got any issues. Okay, it's actually running. Didn't have any typos in there, it looks like. And we're creating these images. So now we just need to sit back and have a cup of coffee while we wait for the rest of these to create. Okay, so we've got all those images generated, and if we go look in that directory, here we are. We have all of our radar images. We can see all these really interesting returns on the radar. And all of this was done without actually having to download the files to the computer and use that level 3 reader, though you certainly could if you wanted. But we've got all these nice figures that we could put in our talk or paper. So I hope that you found this useful and that you'll explore MetPy's new remote data access, and we'll see you on next week's MetPy Monday.